Good morning everybody. Today we will discuss about chapter 2, Computer Science, class 11. Okay, the chapter is Encoding Schemes and Number System. Number system is a very important part for computer science students, and this is the introduction part. Previously in the first chapter we have already discussed that we use the computers, they are all digital computers. Okay, means our computer can understand only zeros and ones, no other characters, right? But when we use the keyboard, there are so many characters from A to Z and also special characters and so many things. Now how computer works, this is the elementary study to know how computer works, and for this reason we use number system and encoding schemes. Now look at this picture. When the key A is pressed in the keyboard, what happens actually? It is internally mapped to a decimal value 65. This is code value, which is then converted to its equivalent binary value for the computer to understand. Similarly, when we press any alphabet on Hindi keyboard, internally it is mapped to a hexadecimal value 0905, whose binary equivalent number is given here. Okay, all these things happens. So what is encoding? The mechanism. Encoding means the mechanism converting data into an equivalent cipher using specific code is called encoding. It is important to understand why code value 65 is used for the key A and not any other value. Is it same for all the keyboards irrespective of their make? Yes, it is same for all the keyboards. This has been possible because of standard encoding schemes where each letter, numeral and symbol is encoded or assigned a unique code. Some of the well-known encoding schemes are described in the following sections. First of all, American Standard Code for Information Interchange. Look, here is the table. I already told you that if you get any table, these tables are important for your exam purpose because many MCQs are preparing from these tables. So this is important for MCQ type question. Ascii code for some printable characters. The printable characters means the characters we used for any printing purpose. See, from A to Z, and from here is also capital letter, small letter, they all are different. You will get this ASCII code for some printable characters are here. You will get that complete chart from internet also. You just go through that complete table for your knowledge. Now ASCII and binary values for word data. See, ASCII code for capital D will be 68, whereas for A 65, T 20, 84, F 65, and their respective binary code is given there. Means 65 for A, the character is A, the ASCII code representation is 65, which is a decimal number, and then we represent it to its equivalent binary form, means the machine language format, only zeros and ones. See, in binary code there is only zeros and ones, and the computer can only understand these zeros and ones. Okay, so first of all we have gone through ASCII. Then comes Indian Script Code for Information Interchange, ISCII. For what purpose this is used? We know for Indian languages. For additional Indian language character set, additional codes have been assigned in the upper region, the aksharas of the language. Okay, and then Unicode. Unicode means there were many encoding schemes for character sets of different languages, but they were not able to communicate with each other, as each of them represented characters in their own ways. Hence, text created using one encoding scheme was not recognized by another machine using different encoding has been developed to incorporate all the characters of every written language of the world. Unicode provides a unique number for every character. This is very important. What does Unicode works like? Unicode provides a unique number for every character irrespective of device. Okay, it may be server, desktop, mobile, anything, irrespective of operating system also. It may be Linux, Windows, iOS, or software application, different browsers, text editors, etc. Commonly used Unicode encodings are UTF-8, UTF-16, UTF-32. It is a superset of Ascii, and the values 0 to 128 have the same character as in Ascii. We can see Unicode table for the Devanagari script, right? What is Devanagari script? You all know that Sanskrit. Here is it. And then comes number system, the most important part of your computer science. Number system. What is number system? The system of numbering. Now see this diagram. We will learn 4 types of number system. First of all, binary, decimal, hexadecimal, and octal. See, in binary number system, the base of number system will be 2. Comprises are 0 and 1. Decimal number system, base 10, comprises 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. This decimal number system is the common number system we always use in our normal life. In our daily life, we use this decimal number system. And then hexadecimal number system, where base will be 16, comprises 0 to 9, and from capital A to F, means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After that, from 10 will be represented as A, 11 will be represented as B, like this, A, B, C, D, E, and F. Total 16. And in octal number system, base will be 8 and comprises are 0, 1, 2, 3, 4, 5, 6 up to 7. Look, the most important part is here. Binary number system. What the name implies? Binary. Binary means 2. So there are 2 digits only used, 0 and 1. In decimal, 10. 10 means from 0 to 9, if you count all the digits, from 0 to 9 it uses 10. And for hexadecimal, 0 to 9 here and A to F. Total number 16. And for octal, same thing. Total number 0 to 7. That means 8. So number systems are also called positional number system because the value of each symbol, that is digit and alphabet in a number, depends upon its position within the number. Number may also have a fractional part similar to decimal numbers used by us. The symbol at the rightmost position in the integer part in a given number has position 0. The value of position in the integer part increases from right to left by 1. On the other hand, the first symbol in the fraction part of the number has position number -1, which decreases by 1, and while dividing fraction part from left to right. You please go through this chart. This is very important to understand number system properly. Here is a beautiful example. You must go through this one. Now comes the decimal number system. All these are in a diagram also. Positional value also for digits, decimal number represented as power of base 10. See, positive numbers, integer part to into this thing, and here after decimal part this thing, fractional part 237.25. this is in decimal number system, right? We write like this. Now binary number system. What is binary number system? The ICs, integrated circuits in a computer, are made up of a large number of transistors which are activated by the electronic signals. Low or high, they receive the on or high and off or low state of a transistor is represented using the 2 digits 1 and 0 respectively. These 2 digits 1 and 0 form the binary number system. This system is also referred as base 2 system as it has 2 digits only. Some examples are here. Now binary value for 0 to 9 digits of decimal number system. See, in decimal number system we use 0, 1, 2, 3, 4, 5, 6 up to 9, and their respective binary numbers are given here. Octal number system is also same thing, but here base will be 8. I have already told you. And here also there is a chart: octal digit, decimal value, and 3-bit binary number. You will go through all these charts. Same for hexadecimal number system, base will be 16, and here is the given chart. Right. Now, application of hexadecimal number system. What are the applications? Why do we need so many number systems? Right. So, main memory is made up of memory locations where each location has a unique address. We all know this. Usually, size of a memory address is 16-bit or 32-bit. To access 16-bit address, a programmer has to use 16 binary bits, which is difficult to deal with. To simplify the address representation, hexadecimal and octal numbers are used. Let us consider a 16-bit memory address, this one. This is the hexadecimal number, right? This one. Using the hexadecimal notation, this address is mapped to C0F1, which is more easy to remember. Remember to this one, this number is easier to remember. So, which is more easy to remember? The equivalent octal representation for the 16-bit value is this one, right? For this reason, we need different kind of number system. Now, hexadecimal numbers is also used for describing the colors on the web page. We use different colors, and each color is made up of 3 primary colors: red, green, and blue, popularly called RGB in short. In most color maps, each color is usually chosen from a palette of 16 million colors. Therefore, 24 bits are required for representing each color, having 3 components: 8 bits for red, 8 bits for green, and 8 bits for blue component. It is difficult to remember 24-bit binary color code, right? Therefore, color codes are written in hexadecimal form for compact representation. For example, 24-bit code for red color is, see here, first 4 bits are ones, then zeros and zeros. The equivalent hexadecimal notation is FF0000, which can be easily remembered and used. And this table shows some examples are here. For some common colors, black, white, yellow, and gray, you please go through. And then comes conversion between number system. This is also very important. I will discuss in the next chapter. In the next class. I think this introductory part you please go through. If any doubts are here, please comment me and ask me. I will definitely try to clear the doubts, and please subscribe my channel to get further notifications. Okay, thank you.